Hey everyone. So in this video, I'm going to start looking at some mental strategies for multiplication in the same way we did for addition and subtraction. Now, this video is assuming that in elementary school or primary school, you have already talked about the timetables and at least have some kind of grasp on memorizing those and just remembering the main numbers. Now, I understand that a lot of you probably know that, and that's why in the first video, I really just wanted to dig deep into what we mean by multiplying numbers and how we can then apply the times tables that we already know. And in this video, I'm going to talk about some strategies for multiplying numbers outside of our timetables. So some bigger numbers here, because when we multiply, we're not just confined by this 12 by 12 grid, going from 1 all the way to 12, all the way to 12, and putting in all our numbers here for our times table. We're not just dealing with those. Multiplication doesn't just end within that table. We need some strategies for multiplying even bigger numbers. So what I'm going to do is I'm going to give you a few questions and we're just going to discuss some ways we can maybe go around doing this. And in doing that, we're also going to talk about another law or pattern we see coming up. Same way we talked about the commutative law in the previous video. Now, for question one, I'm going to try to find what is 3 lots of 13? 3 times 13. Now, I can do this in a similar way as I did before, because we remember that multiplication is just an abbreviation of addition. So I can write this as, well, there's 3 groups of 13. So 13 is being added to itself 3 times. So yeah, we can do that. And then there's a little bit of effort in adding all of these together. So we will get, for example, 13 plus 13 gives me 26. And if I add another 13 to that, that gives me 39. Now that's cool, but there's a chance that we're going to get some bigger numbers than this. So for this particular question, whoops, I want to introduce a strategy to coming up with this. And in doing that, we're going to also come up with this rule. I'll do it for this question and the next one. And then I'll see if you guys can pick up on what's happening here. Now, here, if I wanted to write this 3 times 13, now in my times tables, it only really goes up to 12, doesn't it? So let me try to break up my 13 into a number between, I want to break up this 13 into into 2 numbers between 1 and 12. So I can use what I already know from my times tables. Now, why don't I write this as 13 times 10 plus 3? Okay, that sort of makes sense. Now, because this 13, I can write 13 as 10 plus 3. Now, I'm just going to look up a pattern that comes here in the same way that I had up here. I want to say, okay, I have 3 groups of this 10 plus 3 here. So why don't I just write that here? Well, I have 10 plus 3. That's my first group. I have another group of 10 plus 3. And I have another group of 10 plus 3. I have 3 lots of 10 plus 3, or 3 groups of 10 plus 3, which I've drawn here. I have 1, 2, 3 groups of this. And now, well, I have 3 10s here. So if I add 10 with 10 with 10 here, I'm going to get, because we remember with our associative law from addition, it doesn't matter what order we go in, we can always add these together. So why don't I group these 10s? I go 10 plus 10 plus 10. Okay. And I'm going to add to that 3 plus 3 plus 3. Now, I know, guys, I know I'm going really slowly through this, but I really want to drill the importance of one of the patterns we're going to see emerging here. Now, here I have how many groups of 10? Well, I have 3 groups of 10. So I can write that as 3 times 10. And here I have 3 groups of 3. So I can write 3 groups of 3. Now, from our times tables, you can see that on this side, I'm going to get, sorry, I forgot a plus here. I'm going to get 3 times 10 from my times tables. I know that's 30, or just adding 3 tens. 10 plus 10 gives me 20, plus another 10 gives me 30. And to that, I'm going to add 3 times 3, which from our times tables, we know is 9, or 3 plus 3 gives me 6, plus another 3 gives me 9. So we get 30 plus 9 gives me 39. Now that's the same thing we got up here. We got 39 as well. So let's just hold on to this for 1 second. We're going to try another question, and then we're going to see if we notice anything else happening here. So I'm going to try another question here, another kind of trickier multiplication question. I'm going to, for question 2, try 5 times 24. Now you can see I've got a bigger number here. So I'm not going to draw up like I did in the last video. Okay, 1, 2, 3, 4, 5. Draw these 5 circles and then just do it 24 times. That's going to be way too time consuming. That's why we come up with these strategies and patterns in the first place. Now, instead of doing this, let me break down this 24 into some smaller numbers that make it easier for us to multiply. So I'm going to write this, instead of 5 times 24, I'm going to write this as 5 times, and 24 I can make by doing 12 plus 12. Our times tables go all the way up to 12 in the ones we currently would have learned. So this is like saying, let me write it here. Let's say, this is like saying 12 plus 12 5 times. So I'm adding this 5 times. So plus 12 plus 12 plus 12 plus 12 plus 12 plus 12. And now I would discourage you from doing it this way when you actually work through questions of this kind, but because hopefully by the end of this video, you'll come up with quicker methods. But you can see here that I can count, well, how many lots of 12 do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 groups of 12 altogether. Now, 10 groups of 12, I can write that as 10 times 12. And what's 10 times 12? Well, from our times tables, we should know that that is 120. So, but let's just look at what we did here. Because in doing this, we have added, well, when this 5 multiplied by both these things inside my brackets, well, I thought of this as, well, I have 1, 2, 3, 4, 5 12s here. And I added that with 1, 2, 3, 4, 5 12s. So you can see in doing this, my 5 to find this was actually timesed by 12. And then that was added with 5 times another 12. Think about that here too. We reduced this thing here into into 3 times 10 and 3 times 3, notice that when this was multiplying, well, I just times 3 by 10 here and 3 by 3. Now, this is an example, guys, of what we think of as, and what we now know as, the distributive law. Sorry, can't speak. So the distributive law, and I talked about this in my algebra series for year 7 as well. This tells us that if we have a number, so say 5, multiplying by any number, let's say, I don't know, 3 plus 10, we can find this by first multiplying 5 and 3. That gives me 5 times 3. And adding that to 5 times my other number, 5 times 10. So it makes my multiplication easier. So instead of doing 5 times 13, which this is just another way of saying writing 5 times 13, I can break this up into two numbers that add to give me 13, and then use this distributive law, this pattern that I've learnt so far. And I can do this by going, well, cool, what's 5 times 3? Well, that's 15. Plus 5 times 10 from my times tables, I know that is 50. So this is going to equal 5 times 13 gives me 15 plus 50, which gives me 65. Now, we've done a lot of practice with this, and I want to show you really quickly that it doesn't matter how many numbers we break up into here. This idea will always work, and we can use this strategy for working out some really tricky multiplications. Now, let's look at question 3. Let's do that in black. Let's do, say, 4 times 29. 4 lots of 29. Now, in doing this, I want to break up this 29 into some smaller numbers that are easier for me to deal with. So I can make 29, and you can do this in any way you'd like. That's the great thing here. I can either write this as 20 plus 9, and then say, okay, well, what's 4 lots of 20? That's 20 plus 20 plus 20 plus 20. That gives me 80. Plus 4 times 9, which is 9 plus 9 plus 9 plus 9. I can write that from my times tables as 36, and I can add these together and then go from there. So this gives me 80 plus 36, gives me 116. But I can break this down however I'd like. What if I didn't know what 4 times 20 was? What if I decided to pick some even smaller numbers? Well, I could write this as 4 plus, let's say, 10 plus 10 plus 9. Well, here, I've still made 29 here, but I've just used some smaller numbers and 3 of those smaller numbers to make this. So in doing so, I can say that, well, 4 times 10 here, that gives me 4 lots of 10 from my times tables. That gives me 40. 4 lots of 10 again here. Another number we're going to add is 40. 4 lots of 9 gives me 36. How do I find the total here? How do I find 4 times 29? Well, I'm just going to add all of these numbers together. My 40, and my 36. In doing so, I get 40 plus 40 plus 36. 40 plus 40 gives me 80. And you can see, hopefully now, we're getting to the same spot we did before. 80 plus 36 gives me 116. So this is a really good strategy we can use. Now, just to summarize what I had here, this is the distributive law, and we can apply this to any multiplication of numbers. So this just tells us that once we have any number, we can break it up into a sum of two numbers. So say it's a bigger number like 29, which isn't in our times tables, we can break it up into numbers that we know and that we know the times table for, and then work through it separately. So the distributive law, I talked about this in another video, but I'll just define this one more time. Anytime we have a number multiplying by a sum of other numbers, this step here is what we got up here, as well as up here, when we broke up the 13 into an addition of two numbers. Once we have this type of thing happening, we can times my number on the outside of the bracket with the B inside. And these letters are just to show any numbers here. So my first two numbers multiply and my second two numbers multiply. And the answer I get is going to be the product. So what I get when I times two numbers. So the product of these two numbers added to the product of these two numbers. That is the distributive law, and that is a strategy we can use for multiplying bigger numbers. And you can see it works in a variety of ways. We can pick any numbers within this bracket so long as they add up to the number from our question.